Hello everyone, this is myself Vishakha and I welcome you to my channel Thoda Plus Thoda Minus. Now, in this today's tutorial, we'll be talking about three-dimensional geometry. I have basically divided this topic into two segments. The first, which you guys study in your class 11th, and the second is a bit more advanced level where you guys study in your class 12th. In today's tutorial, we'll be just talking about the very basic stuff of three-dimensional geometry. It's just an extension to what you guys have studied or learned in your two-dimensional plane. The two-dimensional plane, the axis, x-axis and y-axis divide the Cartesian plane into four quadrants. However, when you talk about three-dimensional geometry, the x-axis, y-axis and another z-axis divides the Cartesian plane into 8 octants. Now, how do you find these 8 octants? Let me just explain you in a very practical way. Suppose I have these 3 color pencil. One is X, one is Y, one is Z. So yeah, this is your X axis. Where I am putting this rubber. So this is basically the positive portion. So you guys can acknowledge it, or you guys can understand it that yeah, this is the rubber portion. So this is your positive area, and then this is your negative area. So this is your x-axis, positive x-axis, negative x-axis. Suppose this pink represents your y-axis, so positive y-axis, and this is your negative y-axis. Now this is your two-dimensional plane, plus minus, plus minus. To make it three-dimensional, practically, let's insert this Greek color, which is your z plane, positive z-axis and your negative z-axis. Now you can analyze it very clearly. It's dividing into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So these are basically the 8 octants. Just like in the two-dimensional plane, you have 4 quadrants. In this three-dimensional plane, you have 8 octants. Now how do you divide it? Like 1, 2, 3, 4, 5, 6, 7, 8. So the positive x-axis, positive y-axis and positive z-axis is your first octant. Negative x-axis, positive y-axis and then positive z-axis is your second octant. Similarly, the third, which is negative, negative, positive. Fourth, positive, negative, positive. Fifth, this particular area, I'll just rotate it like this. Positive, positive, negative. Sixth area, negative, positive, negative. Seventh, negative, negative, negative. And then this 8th one, which is positive, positive, negative and negative. So these are your 8 octants. Now suppose the teacher asks you, in which octant does minus 3, 1, 2 lies? So you can very clearly see minus 3 is your negative x-axis, minus 3, 1, which is your y, 1, 2, which is again your positive. So this point lies in your second octant, right? Suppose similarly I ask you minus 3, minus 1, 6. So minus 3, the negative one, minus 3, negative minus 1, say I take it positive, 6. Yeah. So this particular area, which is your third octant. So this way it becomes very easy for you to identify. I'll suggest the class 11 students to please not memorize the table that which octants, what are the signs of your axis. This very simple way, just hold your pencils, just hold your pens like this. Just make sure that they are perpendicular to each other, and it's very simple for you guys to identify in which octants just do your coordinates lie. So let's start with the basic concepts now.
थ्री-डायमेंशनल ज्योमेट्री. अब ये बहुत ही बेसिक टॉपिक मैं आज कवर करने वाली हूँ थ्री डायमेंशनल ज्योमेट्री के बारे में. आई विल जस्ट टॉकिंग अबाउट द बेसिक स्टफ्स टुडे so that you're clear with the concepts, and in the next video we'll talk about a little more advanced level जो कि आप क्लास 12th में पढ़ते हैं. अभी मैं आपको जो बताऊंगी वो जनरली क्लास 11th के बेसिक्स हैं. थ्री डायमेंशनल ज्योमेट्री में आई एम फर्स्ट प्लेस एज्यूमिंग कि आपको टू डायमेंशनल स्पेस बहुत अच्छे से क्लियर है. आपने टू डायमेंशनल कार्टेशियन प्लेन में आपने पढ़ा है, आपके पास एक एक्स एक्सिस होती है, एक्स डैश, एंड एक वाई एक्सिस होती है, वाई डैश. अब जब हम थ्री डायमेंशनल की बात करते हैं, हम एक स्पेस क्रिएट कर देते हैं. फॉर एग्जाम्पल जब आप रेक्टेंगल लेते हैं या आप स्क्वायर लेते हैं तो दैट इज़ योर 2D ऑब्जेक्ट. जब आप क्यूबॉइड या आप क्यूब की बात करते हैं तो ये आपकी 3 डायमेंशनल स्पेस बन जाती है. एसेंशियली दिस मीन्स अगर मैं ये एक्स वाई प्लेन में अगर ये मैं जेड एक्सिस अगर दिस इफ दिस पेन इज़ माई जेड एक्सिस तो दिस जेड एक्सिस इज परपेंडिकुलर, ध्यान से देखिए, टू एक्स एक्सिस एंड टू वाई एक्सिस. देखिए अब इसी तरीके से अगर आप एक रूम को ही इमेजिन कर लीजिए तो एक रूम में आपके पास एक लेंथ होती है, हाइट होती है एंड एक ब्रेथ होती है. ऑन ऑल दीज 3 प्लेन्स आर परपेंडिकुलर टू ईच अदर. तो अगर मैं इसको इस पेज पे बनाना चाहूँ एक्सटेंडिंग इट, दिस इज़ योर जेड एक्सिस. एसेंशियली दिस मीन्स कि अगर मैं आपको इस तरीके से एक प्लेन पे ये फिगर क्रिएट कर दूं तो दिस cuboid is in this xyz plane and this point is denoted by p x comma y comma z, which is your the marking of your point P on your 3-dimensional space. अब हम बेसिकली आपके बात करेंगे आपके मेन फॉर्मूलेस की. फर्स्ट है आपका डिस्टेंस फॉर्मूला which is the distance between 2 point A, B in this 3-dimensional space is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Ab, how do you use these distance formula? I'll start with a very basic question. Suppose you have point P as 1 comma minus 3 comma 4 and your point Q as minus 4 comma 1 comma 2. Now applying distance formula, the distance between 2 points P and Q in the 3-dimensional plane would be x2 minus x1 minus 4 minus 1 square plus 1 plus 3 square plus 2 minus 4 square, and when you solve this you will get root 45, simplifying it 3 root 5 units, which is the distance between 2 points P and Q. Now variety of questions can come in the application form. How do you interpret them? Suppose you are asked the question to prove that 3 points are collinear. Now please listen to this concept very carefully. If you have a triangle ABC, a triangle has a property that the sum of 2 sides AB plus BC, any 2 sides will be greater than your third side. So I have taken AB plus BC is greater than AC. You could have also taken AB plus AC is greater than BC. However, if you're talking about the collinear, the 3 points are collinear when AB plus BC is equal to AC, which means all of the 3 lie on the same lines. How does it look? A, B, C. This AB plus BC is equal to AC. So when the 2 sum is greater than the third side, it is supposed to be a triangle, and if it's on the same line, it holds an equality sign, that is AB plus BC is equal to AC. Okay, so let's do a simple question so that it makes the things clear to you. So let me suppose 3 points P minus 2 comma 3 comma 5, Q 1 comma 2 comma 3, and say R 7 comma 0 comma minus 1. Okay, so you need to prove that these 3 points are collinear, which means we'll find PQ, we'll find QR, and we'll find PR. Use the distance formula. PQ 1 plus 2 square plus 2 minus 3 square plus 3 minus 5 square. When you solve it, you will get something like root 14. You find QR, which is 7 minus 1 square, 0 minus 2 square plus minus 1 minus 3 square. You will get root 56, which is root 2 root 14. You find PR, which is 7 plus 2 square plus 0 minus 3 square plus minus 1 minus 5 square, and solving it you will get root 126, which is 3 root 14. Very clear? PQ plus QR is equal to PR. Root 14 plus 2 root 14 is equal to 3 root 14. So, which shows that the sum of 2 is equal to third, so that points are collinear. Now, the next topic which can be asked is to prove whether the triangle that you have is a right angle triangle, or it could be an isosceles triangle, or it could be an equilateral triangle. For a right angle triangle, your hypotenuse square should be equal to perpendicular square plus base square. That is, say, if you have this triangle ABC, your AC square should be equal to AB square plus BC square. For an isosceles triangle, any two sides should be same. Say AB is equal to AC or AB is equal to BC. Any two sides should be equal except the third one. For an equilateral triangle, all the three sides will be same. सारी की सारी बराबर होनी चाहिए. Let's do a very simple question. Suppose you are given say 3 points. A is 0, 7, 10. You have B minus 1, 6, 6, and say you have C minus 4, 9, 6. Now you need to show whether it's a right angle triangle, isosceles triangle, equilateral triangle, or what, right? So you find AB, or rather if it's a right angle triangle, you can directly remove this under root by finding AB square, which is minus 1 minus 0 square plus 6 minus 7 square plus 6 minus 10 square. When you solve it, you have 1 plus 16, which is 18. You find BC square, which is minus 4 plus 1 square plus 9. BC, 9 minus 6 square plus 6 minus 6 square, which is nothing but 9 plus 9, 18. You find AC square. You have AC minus 4 minus 0 square plus 9 minus 7 square plus 6 minus 10 square. You solving it, 16 plus 4 plus 16, which is 36. Now it's very clear that your AB square plus BC square is equal to AC square, which means it's a right angled triangle. Similarly, you can also be asked to prove whether it's a parallelogram. Then you just need to prove that the opposite sides are equal. The basic thing, the necessity for it to be a parallelogram, right? Now the next part which I need to discuss with you is the section formula. The section formula, this is just the same as you have done in your two-dimensional plane. If any 2 points is divided internally, say in m is to n, then the ratio then is given to you as m is to n, then your x comma y comma z, if this is your x1, y1, z1, this is your x2, y2, z2, and you say this point that is being divided internally is say x comma y comma z, this is nothing but mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n, and mz2 plus nz1 upon m plus n. This is just the same as you've done in the two-dimensional plane. However, if it's divided externally, this n becomes basically minus. So this minus 1, that is xyz, is nothing but mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n, and mz2 minus n z1 upon m minus n. कुछ ज़्यादा फर्क नहीं हुआ है. There has not been much change. So let's do one very simple basic question to make the point very clear to you. Suppose you have point P as 1 comma minus 2 comma 3, and then you have a point Q which is 3 comma 4 comma minus 5, and this point is divided internally. If I talk about internally in ratio 2 ratio 3, then you have basically, if you plot it, it will be very easy for you. 1 comma minus 2 comma 3, and this is 3 comma 4 comma minus 5, and you are dividing it in ratio 2 comma 3 ratio 3. So this will be multiplied by this factor, and this 3 will be multiplied by the first one. You will get 6 plus 3 upon 5 comma 8 minus 6 upon 5 comma minus 10 plus 9 upon 5, which is 9 upon 5, 2 upon 5, and minus 1 upon 5. This is internally. You can also check for externally. If it's externally, just that the sign gets reversed. If I do this question over here for this externally part, you get 6 minus 3 upon minus 1. The sign is negative. 8 plus 6 upon minus 1, minus 10 minus 9 upon minus 1, which is minus 3, minus 14, and 19. Right? So this is when you're given externally. Let's do a very simple basic question. Right? Find the ratio in which points 4 comma 8 comma 10 and 6 comma 10 comma minus 8 is divided by your YZ plane. You need to find the ratio in which this YZ plane divides these points. Suppose you have 4 comma 8 comma 10 over here, you have 6 comma 10 comma minus 8 over here, and there is this YZ plane which divides it in m is to n. Since nothing has been mentioned about internally and externally, we'll assume it's internally only. YZ point, the coordinate will be x, will be holding some point 0 only, and there is this y and z coordinate that will exist because it's divided by YZ plane. You'll use the formula of 6m plus 4n upon m plus n, 10m plus 8n upon m plus n, and minus 8m plus 10n upon m plus n. Now since your x coordinate is 0, 6m plus 4n upon m plus n is 0. That is 6m plus 4n is 0. If you write it in the ratio form, m upon n is nothing but minus 4 upon 6, which is minus 2 upon 3. So this is the ratio. Right. Similarly, we can talk about centroid. Centroid is nothing but when the three medians, the point where the three medians intersect each other. If this is the median, this is the median, this is the median, the centroids divided in the 2 ratio 1. So the coordinates of centroid will be, since there are now 3 points, it's x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, and z1 plus z2 plus z3 divided by 3. So this is the coordinates of the centroid. Now you can be asked some very simple and very basic questions, as suppose the 3 points are given 3 comma minus 5 comma 7. You have been given minus 1 comma 7 comma minus 6, and now suppose you've been given the centroid coordinate as 1 comma 1 comma 1, and you need to find this coordinate of point C. Let's assume this is a question. So C as x comma y comma z. Now use the same formula. You have x plus 3 plus minus 1 upon 3 is equal to 1. You have minus 5 plus 7 plus y upon 3 is equal to 1. And similarly for the z coordinate, you have z plus 7 minus 6 upon 3 is equal to 1. Solving it, you can have x is equal to 1, y is equal to 1, and z is equal to 2. So the coordinates of point C will be 1, 1, 2. Right? These are the very, very basic topics and very, very basic concepts that you can be asked for in the three-dimensional. In the next video tutorial, we'll be studying about direction cosines and direction ratios relating to three-dimensional plane. I hope the basic topic is very clear to you. So if you have any doubt, do let us know. Thank you so much.